Hello, everybody. I'm very happy to be here today at JFall. Today I will be talking about how to modernize our Java applications for Kubernetes, taking that idea a bit further than we're used to. Let's jump in. So, our story begins with the usual dev versus ops problem of throwing applications over the wall and operations having to figure out how to keep them working. Of course, in recent years, we have made a lot of progress on this front, not the least because Kubernetes offers a great platform on which gives us a better level of abstraction where developers can actually run applications in a much more ops-friendly way, describing applications on a higher level than before. So that's great, but where can we take this further? Let's take a look at deploying a Tomcat application, which is, well, basically deploying Tomcat with 2 WAR files to Kubernetes. This is going to be my example today. To do this, we would create a Docker container image with Tomcat inside and the 2 WAR files, and then create a YAML file describing a Kubernetes deployment that would run a certain number of replicas of our image. This works and it's great. The only downside is that ops doesn't really know what this application is doing. There is no visibility into those WAR files, into generally how is this Tomcat configured, what possible configuration parameters does it have. It's still pretty much of a black box. So what we can do instead of this setup is something much more complicated, but much more, but with lots of benefits. We could define 2 new custom resources in Kubernetes. One is the custom resource type Tomcat that would specify what version of Tomcat do we want to run and how many replicas, and another custom resource called web application, and that would define which Tomcat are we trying to run this web application in and what WAR file are do we want to deploy there. Now, Kubernetes supports something called custom resources. That is a pretty simple concept. Custom resources work like regular Kubernetes resources, except we are free to define whatever schema we want to define for them. Now, once we deploy our Tomcat using these custom resources, you can already see that ops will have full visibility into what's happening, what web applications are we deploying, and what Tomcats are we running. We have basically created a domain-specific language describing our application. And in this case, our application is Tomcat, which, by the way, is not really a realistic case. I'm just using Tomcat as an example of a legacy application turned Kubernetes native because it's something every Java developer knows. Now, how do we make these custom resources actually work? Of course, they are just static data at this point. What we do is we deliver an application called the Tomcat-Operator that will be monitoring any custom resources of type Tomcat and webapp on Kubernetes and actually making the magic happen behind the scenes. So actually starting up Tomcats and actually downloading WAR files and deploying them into Tomcat. And this Tomcat operator, we can think of a full automation of operating Tomcat, basically. So it's developed by the development team who is, in our fake case, developing Tomcat, and gives operations, basically automates away a lot of the stuff operations might need to do with Tomcat. So in the end, everybody's happy. The developers can encapsulate the logic of running their application into a working piece of code, and operations have better access to control what's happening with these applications. So what is a Kubernetes operator? The goal of an operator is to put operational knowledge into software. That's what I just explained. A bit more precise definition, a bit more technical one, is operators are software extensions to Kubernetes that make use of custom resources to manage applications and their components. So an operator is driven by custom resources and encapsulates the logic how to manage applications and their components. Finally, a note about writing Kubernetes operators in Java. Java has a mature Kubernetes client called Fabric 8. So usually you don't need anything more than that to write an operator. However, you would still end up with quite some boilerplate code managing Kubernetes events. So me and some of my colleagues are working on a project called the java-operator-sdk to make operator development more easy for Java developers. We believe that Java is a very good platform for creating operators, especially for internal applications of companies that are running on Kubernetes, need this automation, but writing an operator, let's say in Go, would be a hassle for a development team that otherwise works with Java. So let's jump into creating this operator that I've been showing till now. Here we are in IntelliJ. First of all, we want to register these new custom resources with Kubernetes. For this end, we have a YAML file called crd-yaml in which we have two custom resource definitions. One is named tomcats.tomcat-operator.io, and it has a schema, and the schema says it has a version and replicas parameters in its specification, the spec part. And in the status part, it will have ready replicas. So basically it will show the status of how many Tomcats have actually started up. If we look at the sample, this is how it looks like without the status, because this is a specification basically that the status will be updated in Kubernetes. Super simple. Basically, this is an API for ops to provision Tomcats. It's very simple and straightforward and doesn't have any extra things that we don't need. So that's great. Let's see what happens with and without a CRD. We also have a second custom resource, which is web apps that we already discussed before. So let's jump into Kubernetes. Use the Kubernetes client, kubectl, and let's say we will get all pods, or basically pods are containers on Kubernetes, and we have 0 pods running, so no resources found. However, if we ask Kubernetes to get us Tomcats, Kubernetes will ask us what the hell are Tomcats. Kubernetes doesn't know what Tomcats are, neither does it know what web apps are. Actually, I have no idea how does it figure out that it wants to list Tomcat operator IOV1 something. But anyways, it's just not working because Kubernetes doesn't know about these resources. Until, and from now on I'm typing just K for kubectl, it's just an alias, K apply crd.yaml. With this, we are registering our two custom resources with Kubernetes. Now we can type get kubectl get web apps and kubectl get Tomcats. You can see the error has changed from I don't know what the hell web apps are to I don't have any web apps or any Tomcats. So that's great. Kubernetes now understands that web apps and Tomcats are a thing. Time to actually make the logic happen behind these static resources. Let's take a look at the code of our Tomcat operator. So the main class of the operator is the Tomcat-Operator class. All this does is initializes a Kubernetes client, passes it into the Tomcat controller where the actual business logic will be happening, registers the controller with the main operator class object, and then we remove this line, which we don't need right now, and then it registers the Tomcat controller with the operator. So it's all good. Also, we will start up a little web server to health check to provide health check endpoint for our operator. Let's jump into the Tomcat controller class. We can see that this class is currently empty. Will be happening. And kubectl get tomcats. We can see that this class is currently empty. However, we can see what interface do we need to implement. And this is the part where the java-operator-sdk really kicks in. This interface is coming from the java-operator-sdk, and it's the base interface for implementing resource controllers in the operators. We have to implement two methods. One is create or update resource. The other is delete resource. Right now, we don't have them implemented. So if I run this controller, we will see that not much will be happening. However, it's already, we can see that it's running, and we can try to create an actual Tomcat. You remember the sample file we used before? This one here, this says we want to run 2 replicas of Tomcat version 9. So let's Tomcat sample 1, YAML, we created it, and we can see that our operator has reacted to these Tomcat object, to this Tomcat object being created on Kubernetes. However, if now what we would expect is to have 2 Tomcat pods running, they are not running because this controller currently is not doing anything. Okay, let's add some logic now. Check out demo stage 2. Suddenly we have a lot of code in here. Also some code we don't need yet. But that's okay. So here we can see our create or update resource method has gotten much longer. What it does now, it loads it will create a Tomcat deployment. So we will use actually the core Kubernetes deployment concept to create to start up the Tomcats. Basically, we have a deployment YAML file on our class path. This is a normal deployment YAML file. Disregard the var downloader part. We don't have time to go into that yet. And it will start up a Tomcat image. We can see it's version 8 here, but that's just an example, basically, because everything after we load these objects from the YAML file, we will set every dynamic variable in there using Java logic. And where do we get this the parameters for this logic? We can see that we are creating a deployment and we have to set a name for the deployment. Here we have a Tomcat object coming in to this method, and this object is basically the Java mapping of what we created here. So what's in this sample, this Tomcat, is mapped by a class named Tomcat, which has a spec and has a status. And inside Tomcat spec, it has a version and replicas. It's just classic mapping of Java classes to JSON structures. We set the namespace to the same namespace as the Tomcat object's namespace. We set the image to the right image version from the Tomcat object that we specified, and set the number of replicas to whatever is coming from the Tomcat object. So we translate what's in here into a Kubernetes deployment and a Kubernetes service, because we will need a service also to load balance between our Tomcat instances. All right, so once we have all this set up, we will restart the operator and see the magic happen. This time, the operator should create the deployment and the service. Let's check. We say here in this tab, Kubernetes get deployment service and pods. And we can see we have a deployment called test Tomcat1, we have a service called test Tomcat1, and we have 2 pods that were created by this deployment. So the operator has done its job. What this operator doesn't do yet is handle updates. We can see we do all creating logic here. So what that will cause is if we try to edit our Tomcat that is running on Kubernetes now, and we say, oh, we would like 3 replicas, thank you. We edit this, and now our operator kicks in again to do updates. However, our logic doesn't handle updates, so we're getting errors here saying that we're trying to create objects that already exist. So let's add some update logic in there. All right, we can see now that I have moved things out from the creator update resource method into a method for deployments and another method for services. This is just for convenience. Let's jump into the creator update deployment method. Here we can see that when the method starts, we will use the Kubernetes client to get the deployment in the right namespace with the name we expect it to have to see whether there is an existing deployment. If an existing deployment doesn't exist, then we do the create logic the same way as we did before. However, if it does exist, then we actually update it to change to handle a possible image change and a possible change in the number of replicas. We don't have to really worry about which one has changed because Kubernetes will handle that. So let's try to run this. Actually, if we run it, it will already process our previous change event. So even without me doing a change, we should see 3 pods running. It has already happened. You can see the last one started up 5 seconds ago. One thing to note that I forgot to mention till now is that I'm running this operator on my local machine. Basically, an operator is nothing else, just an application connecting to the Kubernetes API, listening to events, and interacting with the API to create more resources inside Kubernetes or even outside of it. There is no reason for me to not do this straight from my local machine, basically. I could package this operator up as a Docker container and deploy it to Kubernetes, and that's how it needs to run in production. However, for a development workflow, this is perfectly fine, and especially for a conference talk where I have limited time, I'm not going to be messing with building images and deploying them to the remote cluster. But everything that is happening, that you see happening here, is happening on a remote cluster in Google Cloud. Okay. So we can see that we can now update. Let's do a more fancy update, and let's downgrade the version of Tomcat from version 9 to version 8. And you can see that our pods are now terminating and new pods are getting created. So our Tomcats are rolling over to version 8. We will not be waiting around for that to actually complete. We will move on. Also, we have a delete method now. Also very important. I didn't mention that we didn't have that before, but it is also the operator's job to delete any resources when the custom, if I would delete the custom resource Tomcat now from Kubernetes, then the operator would have to delete the deployment and related objects. We just need to delete the deployment because the deployment will in turn delete the pods. Okay, we need to do one more thing. When we query Kubernetes, when we say Kubernetes describe our Tomcat object, we would like to see some status here. We don't want the ops people to have to dive in and understand that behind this Tomcat there is a deployment behind which there are some pods, and them need to check whether this property here, how many Tomcats did the Tomcat start up, how many are ready. We want to provide them, if they are working with Tomcat custom resources, we want them to have to only look at the Tomcat custom resource to see the status. So let's make that happen. And here you can see we're diving into more and more complexity of building an operator. You can see that it's not exactly trivial to do this. You have to think of quite a few things. So building operators is a complex endeavor, but it is worth the investment if you have the right case where your automation scenario is important enough. So what happened with the code now, we are actually watching when the operator now starts up. It will put a watch on our deployment object that we created, and we'll watch this property of the deployment object, how many replicas are ready, and we'll always put the number of ready replicas into the status of our Tomcat object. For this, we create a watch on the deployment, and then this watch will have every event received method, and when we receive the event, we update the status of our Tomcat resource. These watches are the things that are used by the java-operator-sdk in the background to actually give you this create or update resource method. But in this case, we have to do it ourselves because we are watching resources that are not managed by the operator directly. So let's restart it and let's see how it will be updating the status of the resource. I'm not actually sure it will right now because there is no changes happening to the deployment. Yep, it doesn't. So we need to make some actual changes. Edit Tomcat. Test Tomcat 1. Oh, no, it actually did. We can see already that our test Tomcat 1 has ready replicas 3. And if I put, oops. So we have just started up 2 more Tomcats. And if we do the describe, ready replicas equals 5 now under status. So we are providing, and you can imagine we could provide any other status variables, whatever is interesting in this section. Cool. So we're nicely managing Tomcats now. However, we always wanted to actually deploy web applications into Tomcat. So let's make that happen. I'm just actually checking out master here. What happened now is the Tomcat controller didn't change. What changed is that we now have a new custom resource called webapp, and we have a webapp controller. And in the main operator class, we are now registering both a Tomcat controller and a webapp controller. So let's see what the webapp controller does. You might be wondering, how are we downloading WAR files into Tomcat? Well, this is not really pretty. It's just for it's fine for a sample and the conference talk. This is not what you would normally do, but it's a nice and easy solution that the operator will actually reach out into the Tomcat container and run wget on the URL that is specified in the webapp object. So if we see webapp sample 1, here we have a sample var file that will be deployed on the context path mysample. So we will just run wget inside all the Tomcat containers to get this sample var downloaded into them. Cool. Let's do that. So we start up the operator, nothing happens first. However, once we create our web app sample, we can see that we executing command wget o mysample_var. This why is mysample_var is because our context path is mysample, and if we name the var file like that, then it's going to create that context path inside Tomcat. Neat trick, and it works. So, and it downloads sample_var. Let's see if that actually worked. This is the first time we'll actually access our Tomcat using their IP address. We can see that we have a service created that is the load balancer, and Google Cloud has created a public IP address for this load balancer for us. So let's put this in here and add the context path mysample. Yay! And this is actually working. And if I'm refreshing this page, this is actually cycling through the different Tomcats. However, all of them have the same var file deployed, so it's not really visible. Let's try to deploy another web application into the same Tomcat actually. So we'll have sample web app 2. However, the Tomcat will be test Tomcat 1. And the context path will be Charlotte, because this is Charlotte's example Jack's var file. Charlotte's a colleague of mine who has actually created most of this demo and has presented it at Jack's London recently. So let's do web app sample 2 YAML. And let's see. There we go. Second web application super quickly deployed. So you can see that now with a completely Kubernetes native interface, we can manage, we can ask Kubernetes, what are our Tomcats and what are our web apps that are currently deployed? And we get everything through the same interface as we are getting our other Kubernetes resources. An interface that is very familiar to operations. So they can use this, we can expose any kind of resources that are useful in the case of our real applications, our real use cases at our real companies for them to manage things and for us to manage things. So it's everything just becomes nicer at the cost of implementing some logic, which is quite a lot of logic. However, there is a lot of possibilities in this logic. Imagine now, let's say you would have some kind of legacy application that would need to be sometimes restarted because it just has a memory leak and runs out of memory. So there is, there is this thing that ops runs a script, some cron job gets run every 3 days to restart the application. That can also be added to the operator. Any kind of operations work can be added to the operator. In the case of Tomcat, let's say we want to store session state in Redis, we can just put that into the operator to actually start up a whole Redis server and configure Tomcat to store session state in Redis, so we don't have to use sticky sessions for a Tomcat cluster. So there is the options are really endless on how we can use operators to manage our applications. I'll jump back to the presentation. So operators are really a new frontier in how we can do DevOps, and we would love to see the Java community jumping with both feet into this new area, where already a ton of operators have been created with Go, especially for tools like MySQL, etc. So that are third-party tools that you will bring to your cluster. However, for your own applications, it makes very good sense to create your own operators using Java. So as this is a pretty new project, we would love you to help us out and join the project. It's new. There is tons of things to do. It's a great learning opportunity for deep Kubernetes. So please check in with us. We have a Discord channel where you can just very easily jump in, ask questions. You can find the code here. There is more samples in there. And yeah, that was it. Thank you very much for listening to me go on and on about Kubernetes operators. Goodbye. Oh, and I will be hanging around on the conference, so happy to answer any more questions you might have.
So with that, we come to the Q&A part of this session. Ádám, if you would be so kind.
Hey, hello everyone. The real Ádám in the real
Ádám. Here he is. So at the end, there was a question on what happens if you were to modify the resources created by the operator. Could you elaborate a bit on what the options are?
Yeah, exactly. That's a really good question, because it shows one of the more complex things that an operator needs to handle. So what happens if to generalize this case would be what happens if the real world changes and we have to now do something about that. So in the Tomcat operator that I'm showing here would actually not do anything. So if the deployment that is created to run the Tomcats would be deleted by somebody, let's say, or edited, then the Tomcat operator doesn't do anything. However, we're already watching the deployment for changes to update the status on the custom resources. So in that logic, we could also detect that something we don't want, that the deployment went to some state we don't want, and we could then restore its state. That's actually exactly what Kubernetes does. Like the controller that is managing the deployment itself and starts up pods based on the deployment. When I would change those pods, it would actually change them back, because it just wants to reconcile reality to what's in the specification.
Right. So there was also a question on Tekton in this context. Does it have any relation, or?
Yeah, no.
None at all. Okay.
So Tekton is a CI tool to like run a sequence of tasks on top of Kubernetes, while operators are basically a constantly running process that does its thing. You could implement certain things an operator does in Tekton, but generally these are two separate areas for.
Okay. So one question I also had was how much effort is it to write such an operator? Because you showed us by going through several stages of your source code, right? Can you tell us something about how much effort there is involved in creating such a operator?
Yeah, it's not negligible. So let's say this Tomcat operator. Because I wasn't like doing it in a straight like over, let's say, a few days, but this person does. But I would say even creating this would be a day or two, and it's just a sample application. So it's creating operators is a significant effort, because you have to cover all kinds of cases, exactly like what happens with the deployment when it would be modified and so on. What happens when it's updated, when something is created, and so on. So this is suitable for where you really want to invest into properly automating something, like, let's say, your core application that you anyway spend a lot of time operating, and now you really want to automate it. Operators give you this full flexibility of, like, because it's in the end it's just Java code, you can do whatever the hell you want in it, and it's but you have to think about it, and you will have to understand. Even with the java-operator-sdk framework, we try to hide as much of the complexity as possible, but there is still plenty of things to cover and think about.
Right, and there was a question on the example that you used, right, to modernize, but you used WAR files. Could you give us some examples of where you used operators in production or in real world scenarios?
Yeah, where I have used them actually in production was a case of actually provisioning infrastructure that partially was provisioning a new CI/CD system for a team. And the interesting part there was that part of this CI/CD system was running on Kubernetes, but it was also running on other Kubernetes clusters, and it was also running outside. Like, for example, we also provisioned the Git repository holding the state of of an environment, for example. So you can provision also things that are not running on Kubernetes, because again, it's just Java code based on Kubernetes custom resources, which is a pretty interesting thing to do, because and I have a sample for that inside the repo of the Java-Operator SDK, where I'm provisioning because the CI/CD case is pretty complex. There's a lot of resources to provision and all that, but that's a real case. And the other one, this database case, is easier to understand, where based on a custom resource, I'm provisioning a database, a schema inside an existing MySQL database. And this is a case where, let's say in your company, you don't want people to be running MySQL databases as they please, right? Because there is backups, there's all kinds of problems with that. However, you might want to be running a MySQL cluster inside which you want teams to be self-provisioning databases, because you don't want everybody to be like sending an email to the DB team to like, okay, I need a new test database or whatever. So you could create an operator that, based on like, teams can create their own custom resource that asks for a database, and then the operator will actually like have admin rights to the MySQL cluster and create the schema inside that database, and then create a secret object back in Kubernetes with the access credentials. So that's what that sample shows. That's, I think, also a very real case of not really automating an application, but infrastructure provisioning case.
Yeah, right. It's the opposite of what your example was in the beginning, right? To help ops understand how to deploy their applications. This is to ensure that teams know how to deploy or are able to deploy
so that's a very different one. And this example was about like automating an application. That one is infrastructure provisioning for ops. Yeah. So actually you can use operators for many different things. And I have a hard time in like these 30-minute talks to cover a bit of that on like, so I'm always using some different example and yeah.
Okay, so I guess those were the questions. Thank you very much for a very interesting presentation. And thank you very much to the audience for watching this, and enjoy the rest of JFall.
Yeah, thank you very much for having me and for watching the talk, people. Thank you.